Hello everyone, I am Bhavya Rakheja and I am a PhD student in Solve. I work here at Angstrom Laboratory in the Department of Material Science and Engineering and also partly in the Department of Chemistry. I work towards the development of perovskite based solar cells, especially the metal halides one. So it's no surprise how much of a progress this material has made in a very short span of time. Right from 2009 when the efficiency was around 4% to now which is more than 25%.
Now let's have a look at perovskites. They have a formula of ABX3 where BX6 forms octahedra and A occupies the spaces between them. Their remarkable properties include band gap tunability, which can be adjusted between 1.4 to 3 eV simply by varying selected elements. They also exhibit a high absorption coefficient, enabling efficient electron-hole pair generation. Additionally, perovskites have high charge carrier mobilities and long carrier lifetimes, enhancing charge extraction and contributing significantly to the power output.
So when we look at the solar cell structure, we have multiple layers and they are stacked on top of each other. Of course, perovskite, which is the absorber, is the heart of the structure, but there are other layers which sort of support this layer. So similarly, there are transport layers in between which our perovskite absorber lies, and these transport layers provide selectivity to the two kinds of charge carriers. So I work towards the development of these transport layers using atomic layer deposition technique.
Atomic layer deposition or ALD is a thin film growth technique that allows precise control of film thickness at the atomic level. In an ALD cycle, first reactant A is introduced, which binds to the substrate surface. It is then pushed and then reactant B is introduced in the chamber, which then reacts with the adsorbed reactant A. This process is then repeated many times to achieve the desired value of thickness. What excites me the most about my research is its interdisciplinary nature. It allows me to combine chemistry, material science, and engineering to study materials on both scientific level as well as in real-world application. Developing the understanding of materials and seeing it being applied to solar cell makes the work really exciting. Solve Competence Center combines not just the material aspect but broad energy system. It includes its economy, market, as well as land use of the solar panel. So it gives a broader, well-rounded perspective on the future of solar energy. My day-to-day activities involve synthesizing materials in both chemistry labs as well as in the clean room. My work involves synthesizing perovskites using solution-based approach, where we first prepare the precursor solution and it is then deposited on the desired substrate using spin coating method. Finally, the deposited film is annealed on a hot plate to obtain the crystalline film. After depositing perovskite film, other layers are then deposited using spin coating, ALD or evaporation. And finally, we obtain our finished solar cell structures. Afterwards, we study these materials as well as their solar cell performance using different characterization. The images shown here demonstrate how these materials and solar cells look at nanometer scale. In this project, we mainly focus on studying the interface formation between perovskite layer and ALD-based transport layers. This is done using a method known as hard X-ray photoelectron spectroscopy. It is non-destructive in nature and we study how chemical environments evolve at the interface. This could really be important for solar cells, especially for the transport of charge carriers. Finally, we assess different systems and our aim is to be able to deposit ALD layer directly on top of perovskite.
My work could offer exciting potential towards solar cell production. Techniques like atomic layer deposition, which is scalable in nature and at the same time reducing the number of layers in a solar cell structure, could make the production at the module level way more feasible. Thank you so much for watching this video. I hope I could give you a glimpse of the work that we are doing here at the Angstrom Laboratory.